Question number 5 is very similar to question number 4. Question number 5 is still dealing with density, but this time we're going to have to manipulate our numerator, our values for the mass, in order to determine the density. So I have a little bit of notes written out for you already. You could go ahead and copy those down, or I'm going to walk you through them step by step as you watch this video. So the question says a flask that weighs 345.8 grams. So just an Erlenmeyer flask on its own, you take the mass of it. The mass alone is just 345.8 grams. You now fill that flask up with 225 milliliters of a compound called carbon tetrachloride. Carbon tetrachloride is made up of 1 carbon and 4 chlorines. If you now go back and take the mass of the flask filled with the 225 milliliters of carbon tetrachloride, then now it's going to have a heavier weight. It's going to have a heavier mass. So now your mass is 703.55 grams. So I have those highlighted for you, and I have them written out for you in blue. It's the same data that's in the question. The question specifically wants you to use the information and calculate the density of carbon tetrachloride alone. So you're still calculating density, so that means that it's still going to be mass divided by volume. Your volume is just the 225 milliliters. That's the only data you have for volume, but your mass is where you're going to have to do a little bit of subtraction. So the total mass of the flask with the carbon tetrachloride is 703.55 grams. If you now take this value and subtract 345.8 grams, you're going to be left with the mass of the carbon tetrachloride alone, which is what you want. So that's your numerator. Your denominator is just straight data from the problem, which is 225 milliliters. If you go to your calculator and clear out your numerator, 703.55 grams minus 345.8 grams, that's going to now give you 357.75 grams. Your denominator is still the same. It's still just 225 milliliters. If you again clear this out in your calculator and you get rid of your fraction, you do 357.75 divided by 225 milliliters, you're then left with a calculation answer of 159. If you go back to your question and you look at your data remaining, the only units remaining are grams in the numerator and milliliter in the denominator. So that means that your final units are going to be grams over milliliter, which is a completely acceptable unit for density. Density is always mass divided by volume. Grams represents the mass, milliliter represents the volume. Your last thing is always significant figures. So the operation that you were doing here was division. Division and multiplication use the smallest number of sig figs from the data. So you had a little bit of data here. You had 345.8 grams, which is 4 sig figs. You had 225 milliliters, which is 3 sig figs. And then you had 703.55 grams, that's 5 sig figs. So the smallest number of sig figs comes from your volume. So in this case, your calculation answer was 3 sig figs to begin with. You don't have any numbers to use for rounding, and so your final answer is going to be 101.59. Your unit is grams over milliliter, and this right here is your final answer.